Continuing section 2.4, so we just looked at an example where we were integrating a function of two variables with respect to x and then with respect to y, and we saw how we get this. So next thing is how do we know that an equation is exact, or what is the test for checking the exactness? So when we are given an equation like this, that if we have a function of xy multiplied by the differential dx plus another function of xy multiplied by the differential of y, and the sum is equal to 0, we call this an exact equation if the partial derivative of m with respect to y and the partial derivative of n with respect to x, they are same. Then we say the equation is exact. And how do we solve this exact equation? So the method is written here. If you want, you may read it, but I think I will just do the example and explain. But just quickly look at part in the step A. So it says if m dx plus n dy is equal to 0 is exact. So if you see this is an exact equation, then automatically you will say that you have some function big F such that the partial derivative of f, big F with respect to x is equal to the m, given m, and the partial derivative of the partial derivative of f with respect to y will be equal to n. Okay. So this and then partial f by partial y will be equal to n. Okay, so these automatically exist. And then we integrate. So let me show you example. I think it will be easy to understand. Okay, so we are given, first thing is it says classify as exact or not, and then solve if possible. So first we have to check whether the equation is exact or not. If it is exact, then we can possibly solve it. Otherwise, if it is not something that we have seen, we cannot solve that. So if you notice now here, the given equation has some function of x and y multiplied by the differential d of x plus another function of xy and multiplied by the differential dy is equal to 0. Is it an exact equation? Well, you cannot say right now, but what you have to do is you say this is m. So let's say m is equal to 2x plus y, and this quantity is n. So you'll say n is equal to x minus 2y. Okay. So the first one, you have to differentiate it with respect to y. So partial m by partial y. So you get the derivative of 2x will be 0 and the derivative of y will be just 1. And now we do partial n by partial x. So the derivative of x will be 1 and the derivative of minus 2y is 0. So you see these two are same. So we have partial m by partial, or we can just put an equal to in the middle. So exact. So it is exact, and now we have to solve it because, okay. So when we are doing it, so now we say, okay, since this is exact, it means there exists an f. So that and partial f by partial y is equal to n. So so these are kind of two equations, 1 and 2. We can use either to start. So I'm going to use the first one. So I'll say, okay, partial f by partial x is equal to m. So that, which means I can get my f if I differentiate m with respect to x. So m was 2x plus y, so integrating 2x plus y dx will give me 2x squared over 2, so x squared plus xy, and then plus a function of y, so g of y. Now when we now differentiate with respect to x, what happens? Sorry, when we differentiate f with respect to y now. So you get x plus g prime of y. Because the derivative of this is 0, the derivative of this y will be 1, and x is treated as constant, so it just stays. So x into 1, which is x, plus the derivative of g of y, which is g prime of y. But then this is equal to n, which is actually x minus 2y. Now comparing these two, you can say that g prime of y is equal to negative 2y. So we can get g of y which is the integral of negative 2y dy, which is equal to negative y squared, because we have a 2 in front, and then we get y squared over 2, the 2 and 2 cancel out, so we are left with negative 2 and negative y squared. Therefore, our f of xy, so we can now go back and plug it in the f. So f xy is equal to, so we had already found it, it's x squared plus xy plus, actually minus y squared. And then we usually say this is equal to c. So how do I write my final answer? So we'll say x squared plus xy minus y squared is equal to c. So this is how we solve the exact equations.